Alright, in this video we're going to go over problems 18 through 21 on the multiple choice. For number 18, the question is asking what is the value of g prime of 3, and you are given g of x, and you are given the graph of this function as well. Now this is an integrally defined function, this is what this is called, and if you remember back to the second fundamental theorem of calculus, if you take the derivative of an integral and your lower bound is a constant, all we're doing is we're dropping this 2x, this upper bound, into this function here. So when I take the derivative g prime of x, this is going to be f of 2x, but then if my upper bound is something other than a constant or something other than x, I need to take the derivative of that and multiply it. That's the chain rule. So we drop 2x inside, but then we need to derive 2x, so we're going to multiply this by 2. So if g prime of x is equal to f of 2x times 2, then we need to plug in a 3 for x to find g prime of 3. So this makes this f of 6 multiplied by 2. And to figure out what f of 6 is, we're given the graph of f up here. And somebody recreated this graph from the original test that was released, so this is not exact, but on the original test, this graph, this line touched exactly at -1 here, so this graph is a little bit off, but it should touch exactly at -1. And so this is going to be equal to -1 times 2, which is equal to -2. C is your answer here. For number 19, this question gives us the slope of some curve, and the slope is 2x plus 3 everywhere. So I already know that f prime of x is going to be equal to 2x plus 3 no matter what. It asks us which of the following is an equation of the curve it passes through, if it passes through the point 1, 2. So we need to figure out what is the original function that passes through the coordinate 1, 2. So we need to take the antiderivative of 2x plus 3. That's going to be x squared plus 3x. But then we don't know what this constant c value could be, but given this original point, this initial condition, we know that 2 is going to be equal to the function when 1 is plugged in. So 1 squared plus 3 times 1 plus c. So when you solve that, you should get that c is equal to -2. And that's going to be this guy right here. Now this is one of those questions that if you didn't know what to do from this point, don't guess A, B, or E, because you know that the antiderivative of 2x plus 3 at the very least is going to be x squared plus 3x. So it's between C and D. If you don't know how to solve for the initial condition, you're at least not guessing A, B, or E. You know it's between C or D. And once you solve the initial condition, you get that C is equal to -2. Number 20 is Maclaurin series. Okay, when you have this series of terms here. And we need to figure out what is the original function for this Maclaurin series. And so, just by looking at the pattern of points here, I can already see that my exponents are increasing by 1, 4, 5, 6. And so that kind of rules out any cosine or sines because those alternate and they skip some of the exponents. So we know that if there's a sine or cosine in there, it can't be following this type of a pattern. They're all positives, they're not alternating, and if you look at the exponents, they're not skipping any exponents. So automatically we can get rid of A, B, and C. Now it's between D and E. If I look at both of D and E, they both have an e to the something in them. And we do know that e to the x is, the Maclaurin series for e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, so on and so forth. And if I look at my exponents and what they are, what the bases of those are, it's just an x here. And so thinking about if I were to plug in an x squared into each of these, if I'm replacing this x here, if I'm replacing this x squared here, that's going to change all of these to be even exponents. So I don't think it would be e because of that reason. Now if I look at d, it says x squared times e to the x. Let's not worry about these two just yet because they're being subtracted. Let's first focus on this x squared. If I multiply e to the x times x squared, that means I'm multiplying each of these terms with an x squared. So this would be rewritten as, if I do x squared times e to the x, that would be 1 times x squared, which is x squared, plus x times x squared, which is x cubed. And if I keep doing that with the rest of these terms, this is what I should get. Okay, so now I have this right here. Now if I look at my original given Maclaurin series, it starts at x to the 4th over 2 factorial. That starts right here. So I want to kind of cut this right here. Now if I want to move these two over, I would subtract them. And that's why we have this right here. Minus x cubed minus x squared. So this one's going to be d. Okay. And the last. Alright, and the last one, number 21, this was a logistic differential equation problem, and this was not something that we explicitly went over during the year. However, you may have seen a few questions here and there on your mock or on another practice problem or something. But so, to kind of briefly go over what some things about logistical differential equations is that in the form dy dt is equal to k times y times 1 minus y over L. So this is the general form of a logistic differential equation. It's a differential equation, you have dy dt, and this is the general form here. And there's a few things to know about this is that k is a constant. Y, where we see y, that's like your original function. So it's like this variable here is representing an entire function. So your differential equation is in terms of the original function itself. Okay, so like I said, k is just a constant, and L is what we call a carrying capacity. And if you were to look at this on a graph, if you think back to one of your multiple choice mock problems, it asks what does this differential equation look like, logistical differential equation. It always looks something like this. And there's a horizontal asymptote here. Now for a logistical differential equation, if it is in this form, this value L, that is your carrying capacity. That is what we call that. Carrying capacity. And it has to be in this form here. It has to be 1 minus y over L, and then k times y in front. If this is some other number up here, you need to manipulate this to make it be 1 minus y over whatever this value is here. So this L is a carrying capacity. And if you think about the context of this question, it's talking about the moose in National Park is modeled by this function. So if you think about the carrying capacity, like the maximum value of what the value of the moose could be, is whatever that carrying capacity is. So in general, that value L is this horizontal asymptote. So there's nothing you really have to do to solve this differential equation. It's just about knowing what does this mean and what do each of the parts mean in this differential equation. So the carrying capacity is the L if it's 1 minus the function divided by some value. The carrying capacity is going to be 200. This answer is going to be B. Okay. And there's probably more videos out there on Khan Academy or on YouTube that you can find that will go more in depth on logistical differential equation.